may be there, but mostly theoretical you have to write. And tomorrow I'll give you the exact pattern of questions. Today I'll set the questions. Tomorrow I'll tell you how many questions will be there, how many you have to answer. So uh, tomorrow you must attend 8 o'clock in the morning. I'll highlight what are the pattern of question coming in the mid-semester examination. So we have many many things relating to surface mining technology. So here is an overview of surface mining projects and what are its environmental impacts. So you know that any proposed mining projects, uh, let me any proposed uh, mining project, uh, any proposed mining projects uh, vary according to the type of metals or materials to be extracted from the earth. What type of material you are going to mine, whether it is a coal mine or whether it is an iron ore mine, depending on that, you have to uh, carry out the surface mining projects. The majority of proposed mining projects involve the extraction of ore deposits such as copper deposits, nickel deposits, cobalt, gold, silver, lead, zinc, molybdenum, and platinum. So these are the different type of minerals you mine from the surface mining projects. So whenever you go for mining, the environmental impacts of large scale mining projects involving these metals ores are the subject of this guidebook. The guidebook does not discuss the mining of ores that are extracted using strip mining methods, including aluminum, bauxite, phosphate, and uranium. The guidebook also does not discuss mining involving extraction of coal or aggregates such as sand, gravel, and limestone. So there are different phases of a mining project are there. How to start a mining project? Uh, so there are different phases of a mining project, beginning with mineral or exploration and ending with post-closure period. So first the exploration activity is to be carried out. After that the mining will be done, and after all the mineral is extracted, then you have to close the mine. You have to close the mine. Class Rich. So after the mining is completed, then you have to go for closing the mine closure. So according to your mine closure plan, the mining is to be closed. So after that, what follows are the typical phases of a proposed mining project. Each phase of mining is associated with different sets of environmental impacts are there. So whenever you go for mining, so mining affects the environment. So the first phase of mining is your exploration. First you have to explore the mineral deposit. After that only you can go for mining. So a mining project can only commence with knowledge of the extent and value of the mineral or deposit. The information about the location of the mine and value of the mineral deposit is obtained during the exploration phase. This phase includes surveys, field studies, and drilling test boreholes and other exploratory excavations. The exploratory phase may involve clearing of wide areas of vegetation, typically in lines, to allow the entry of heavy earth-moving machineries mounted with drilling rigs. Many countries require a separate uh, environmental impact assessment. Environmental impact assessment plan for the exploratory phase of a mining project, because the impacts of this exploration phase can be profound, and further phases of mining may not ensue if exploration fails to find sufficient quantities of high-grade mineral ore deposits. So if you get high-grade mineral deposits, then you have to go for mining. Otherwise, uh, mining will not be viable. Therefore, the exploration phase, the most important phase of your mining activity. And exploration is carried out by the geologists. The geologists, they explore the mineral deposit, find out the grade of the deposit, they find out the uh, deep strike length of the deposit, and they also find out the total ore reserve in the deposit. After that, only the mining engineers will come and exploit the mineral deposits. So after the exploration phase is carried out, then you have to go for the development stage. What is development phase? If the mineral or exploration phase, if the mineral or exploration phase proves that there is a large mineral deposit of sufficient grade, then the project proponent may begin to plan for the development of the mine. This phase of mining has several distinct components are there. During the development phase, what are the things to be done? First, you have to construction of access roads. Wherever the mining is to be started, you have to reach to the mining area by constructing the roads. Construction of access road is the first phase of development. The construction of access roads, either to provide heavy earth moving equipment and supplies to the mine site, or to ship out processed metals, minerals, and ores, can have substantial environmental impacts, especially if access routes cut through ecologically sensitive areas or are near previously isolated communities. If a proposed mining project involves the construction of any access roads, then the environmental impact assessment for the project must include a comprehensive assessment of the environmental and social impacts of these roads. So during the first phase of mining, you have to construct the roads, access roads to reach to the mine area. And during the construction of the roads, if the road is going through the forest area, then you have to cut the trees. So there will be a lot of environmental impact and social impact at the time of constructing the roads to reach the mineral deposit or mining area. Second phase under the development is site preparation and clearing of the debris. Site preparation and clearing of the debris. So wherever there is mineral deposit, before the mining started, you have to clean this surface. You have to prepare the mining site and clear the debris. If a mine site is located in a remote undeveloped area, the project proponent may need to begin by clearing the land for the construction of staging areas that would house project personnel and equipment. Even before any land is mined, activities associated with site preparation and clearing can have significant environmental impacts, especially if they are if they are within or adjacent to ecologically sensitive areas. The environmental impact assessment must must assess separately the impacts associated with site preparation and clearing activities. So, uh, clearing activities. Then further, uh, after that, after site preparation is done and clearing of the debris is done, then your mining activities will start. Once a mining company has constructed access roads and prepared staging areas that would house project personnel and equipment, mining will commence. All types of active mining share a common aspect: the extraction and concentration, beneficiation of a metal from the earth. So any mining activity you are going to do, you have to extract the mineral deposit. After extraction of the mineral deposit, the mineral is to be beneficiated. Concentration will be carried out to get the metals. Proposed mining projects differ considerably in the proposed method of extraction of the mineral deposit and concentration of the uh, mineral to get the metallic ores from the metallic ores. So, therefore, in almost every case, metallic ores are buried under a layer of ordinary rock or soil, which is called your overburden or waste rock. That must be removed or excavated to allow access to the ore deposit. So every mineral deposit is covered by waste materials, waste rock, overburden material, soil, subsoil. So first you have to remove the topsoil, after that the subsoil, then soil, after that rocks uh, are to be removed, overburden is to be removed, then only you can come to get the mineral deposits. The first way in which proposed mining projects differ is the proposed method of moving or excavating the overburden. First, you have to move, excavate the overburden. After that, only you can get the mineral deposits. What follows are brief description of the most common methods of mining. We have discussed what is open pit mining. So open pit mining is a type of strip mining. Open pit mining is a type of strip mining in which the ore deposit extends very deep into the ground, necessitating the removal of layer upon layer of overburden and ore. In many cases, logging of trees and clear cutting or burning of vegetation above the ore deposit may precede removal of the overburden. The use of heavy earth moving machineries like your bulldozers, dumpers is the most common means of removing the overburden. Open pit mining often involves the removal of natively vegetated areas and is therefore among the most environmentally destructive type of mining, especially within tropical forests. If the mineral deposit is lying in the forest area, so the environment is going to be affected. The ecological imbalance is going to take place because of your mining activities. So, because open pit mining is employed for ore deposits at a substantial depth in the underground, it usually involves the creation of a pit that extends below the groundwater table. In this case, groundwater must be pumped out of the pit to allow mining to take place. Otherwise, the mine will be flooded with water. A pit lake usually forms at some point in time after mining stops and the groundwater pumps are turned off. So we have also discussed what is a placer mining. Placer mining is carried out by hydraulic mining and bulldozing, hydraulic mining and dredging. So placer mining is used when the metal of interest is associated with sediment in a stream, bed, or floodplain. So in placer mining, bulldozers, dredge machines, hydraulic jets of water, which are called your hydraulic mining, are used to extract the placer mining deposits. Placer mining is usually aimed at removing gold from stream, sediments, and floodplains. Because placer mining often occurs within a stream bed, it is an environmentally destructive type of mining. The environment is going to be affected because of the placer mining activities, releasing large quantities of sediment that can impact surface water for several miles downstream of the placer mine. And you have studied, or you are going to study about the underground mining methods. In underground mining, a minimal amount of overburden is removed compared to the surface mining projects to gain access to the ore deposit. Access to this ore deposit is gained by tunnels or vertical shafts, inclined shaft, vertical shafts, or adits. Tunnels or shafts lead to a more horizontal network of underground tunnels that directly access the ore body. So in an underground mining method called stoping method or block caving method, uh, uh, rock are removed in vertical strips that leave a connected underground rock cavity that is usually filled with cemented aggregate and waste rock. So, although underground mining is a less environmentally destructive means of gaining access to an ore deposit, it is often very costly. Underground mining is very costly compared to open cast mining method, and it entails greater safety risks. Underground mining is very hazardous mining. As from safety point of view, surface mines are very safe compared to the underground mining. Underground mining is very unsafe method of mining or very hazardous mining method. Uh, so, uh, while most large-scale mining projects involve open pit mining, many large underground mines are in operation throughout the world. Then, uh, uh, reworking of inactive or abandoned mines and tailings. So after the mining is done, then you are going to uh, dump the tailings or dispose the tailings after the mineral is processed, and you are going to abandon the mine after the mining phase is over. So some mining projects involve the reworking of waste piles from inactive or abandoned mines or older waste piles at active mines. Typically, this is proposed when more efficient methods of metal beneficiation have made it economical to re-extract metals from the old mining waste products. So the material from the piles may be sent to processing facilities on site or offsite. Mining projects that only involve the reworking of abandoned mine waste piles avoid the environmental impacts of open pit mining and placer mining, but still it entails environmental impacts associated with purification, beneficiation of metals from the waste piles. So in open cast mining, you have to dispose the overburden and waste rock. Disposal of overburden and waste rock in almost every project, metallic ores are buried under a layer of ordinary soil rock called overburden or waste rock that must be moved or excavated to allow access to the metallic ore deposit. For most mining projects, the quantity of overburden generated by mining is enormous. Huge amount of overburden material is to be handled in surface mining projects depending on the stripping ratio. Uh, the ratio of the quantity of overburden to the quantity of mineral ore is called your stripping ratio, which is usually greater than 1, thus, and can be much higher also. For example, if a proposed mining project involves the extraction of 100 million metric tons of mineral ore, then the proposed mining project could generate more than 1 billion metric tons of overburden and waste rock. These high volume waste materials, sometimes called the overburden materials, which contain significant levels of toxic substances, which are usually deposited on the side mining site, either in piles on the surface or as backfill in open pits or within underground mines. Therefore, the environmental impact assessment for a proposed mining project must carefully assess the management options and associated impacts of overburden disposal. So since you are going to handle huge amount of materials from the surface mining project, so you should be very careful to stack the overburden materials at a appropriate place so that it is not going to affect the environment. So from your mining projects, you are going to extract the ore extraction. So after a mining company has removed the overburden material which is lying above the ore deposit, the extraction of mineral begins by specialized heavy earth moving equipments and mining machineries such as loaders, shovels, payloaders, backhoes, dumpers, trucks are used for transporting the ore to the processing facilities using your haul roads. So this activity creates a unique set of environmental impacts such as emission of fugitive dust from the haul roads. If you visit the mining areas, open cast mining areas on the haul road, a lot of dust is generated, which is an uh, environmental impact assessment point for a proposed mining project should assess separately how to handle the dust, how to suppress the dust so that the fugitive dust is not going to affect the mining environment. So after the mineral is extracted, you have to go for beneficiation of the mineral deposit. So beneficiation or processing of the mineral deposit. So although metallic ores contain elevated levels of metals, they generate large quantities of waste materials. So at the time of processing the mineral deposit, the gangue particles, the waste materials are to be separated from the minerals. So huge quantity of waste material you are also going to generate from the beneficiation plant. For example, the copper content of a good grade copper or maybe only 1/4 of 1%. The gold content of a good grade gold or may be only a few hundredths of a percent. Therefore, the next step in mining is grinding or milling the ore and separating the relatively small quantities of metal from the non-metallic material of the ore in a process called beneficiation. And after that, milling is to be carried out. Milling is one of the most costly parts of beneficiation and results in very fine particles that allow better extraction of the metal. However, milling also allows a more complete release of contaminants when these particles become tailings. Tailings are obtained after the beneficiation is done. Tailings are what remains following milling of the ore to fine particles and extraction of the valuable metals from the ores. Beneficiation includes physical or chemical separation techniques such as by gravity concentration technique, magnetic separation technique, electrostatic separation technique, flotation technique, solvent extraction, electrowinning, leaching, precipitation, and amalgamation, often involving the use of mercury for extraction of gold. Wastes from these processes include waste rock dumps, tailings, heap leach materials for gold and silver operations, and dump leach materials for copper leach operations. So leaching involving the use of cyanide is a kind of beneficiation process usually used with gold mining, silver mining, and copper mining that merits separate attention because of the serious environmental and public safety impacts associated with the cyanide. Cyanide is very dangerous chemical which can impact the environment. So with leaching, finely ground ore is deposited in a large pile called a leach pile on top of an impermeable pad, and a solution containing cyanide is sprayed on top of the pile. The cyanide solution dissolves the desired metals, and the pregnant solution containing the metal is collected from the bottom of the pile using a system of piles. So in the beneficiation process, you are going to get a lot of tailings. Uh, how to dispose the tailings after the mineral is beneficiated? As previously discussed, even high-grade minerals consist almost entirely of non-metallic materials and often contain undissolved toxic metals such as cadmium, lead, and arsenic. These are very hazardous materials. Cadmium, lead, and zinc, which are heavy metals, which are carcinogenic also, and they are very dangerous to the environment. So you cannot throw them to the environment. You cannot dispose these materials to the environment because they are very dangerous elements like your cadmium, lead, and arsenic. They will affect the human health. So the beneficiation process generates high volume waste called tailings, the residue of an ore that remains after it has been milled, and the desired metals have been extracted. With cyanide for gold extraction, sulfuric acid is used for copper extraction. So if a mining project involves the extraction of a few hundred million metric tons of mineral ore, then the mine project will generate a similar quantity of tailings. A lot of tailings will be generated which may contain cadmium, lead, arsenic, and uh, cyanide, sulfuric acid by using for extraction of the minerals. So they are very harmful to the environment. How a mining company disposes of this high volume toxic waste material is one of those central questions that will determine whether a proposed mining project is environmentally acceptable or not. The key long-term goal of tailings disposal and management is to prevent the mobilization and release into the environment of toxic constituents of the tailings. An entire section of this section is devoted to a detailed comparison of tailings disposal options. These options include use of a wet tailings impoundment facility or tailings pond. Usually tailings dams are constructed to collect the tailings from the mines, and after the tailings are treated, then only the treated water is allowed to go downwards. Dewatering and disposal of dry tailings as backfill is also carried out. Submarine tailings disposal is also carried out. The first option, tailings pond, is by far the most commonly used option in mining areas, but the second option, dry tailings disposal, is most circumstances the environmentally preferable option. The third option, that is your submarine tailings disposal, is sometimes proposed with mine sites located very near to the deep sea environments or in rare instances in freshwater lakes. So this submarine tailings disposal has a poor environment record in the few instances where it has been practiced. Before the adoption of environmental laws and standards, many mining companies simply dumped the tailings in the nearest convenient location, including nearby rivers and streams. Some of the worst environmental consequences of mining have been associated with the open dumping of tailings, is practice now nearly universally rejected. The International Finance Corporation of World Bank Group explains riverine, rivers, lakes, and lagoons or shallow marine tailings disposal is not considered good international industry practice. By extension, riverine dredging, which requires riverine tailings disposal, is also not considered good international practice. So these are the things you have to take into account while mining these surface mining projects, because the environment is going to be affected because of your surface mining projects. So after the mining is done, the mining site is to be reclaimed, reclamation activities to be carried out. This is the last phase of your mining. And finally, you have to close the mine. So site reclamation and closure of mining. So as per the mine closure plan, you have to close the mine. And as per your environmental impact assessment plan, environment management plan, you have to reclaim the mine out area. So when active mining ceases, after mining is over, mine facilities and the site are reclaimed and closed. The goal of mine site reclamation and closure should always be to return the site to a condition that most resembles the pre-mining condition. So what is reclamation? After the mining is carried out, the land should be reclaimed and bring back to its original form. Mines that are notorious for their immense impact on the environment often made impacts only during the closure phase when active mining operations ceased. These impacts, environmental impacts, can persist for decades and even centuries. Therefore, the environmental impact assessment for every mining project must include a detailed discussion of the mine reclamation plan and mine closure plan offered by the mining company. So mine reclamation plan and mine closure plans must describe in sufficient detail how the mining company is going to restore the land to a condition that most resembles the pre-mining environmental quality, how it will prevent in perpetuity the release of toxic contaminants from various mining facilities such as abandoned open pits and tailings impoundments, and how funds will be set aside to ensure that the costs of reclamation and closure will be paid for. An entire section uh, uh, of we can discuss about the reclamation and mine closure uh, uh, plan for the mining projects. So whenever you go for mining, there are environmental and social impacts are associated with every open cast mining. So the uh, and the remainder of this, we are going to discuss about the environmental impacts of mining projects. So whenever open cast mining is carried out, there is impact on water resources. Perhaps the most significant impact of a mining project is its effects on water quality and availability of water resources within the project area. Key questions are whether surface and underground supplies will remain fit for human consumption, whatever water coming out from the mines, whether they are potable, whether the water can be used by the people or not, and whether the quality of surface waters in the project area will remain adequate to support native aquatic life and terrestrial wildlife. These are the things to be taken care. So in mining areas, there is a problem of water pollution, which is called your acid mine drainage, and contaminant leaching takes place because of your mining activities. So acid mine drainage and contaminant leaching is a great problem in mining areas. The potential for acid mine drainage is a key question in mining areas. The answer will determine whether a proposed mining project is environmentally acceptable or not. When mining when mined materials such as the walls of open pit mines and underground mines, tailings, waste rocks, heap and dump leach materials are excavated and exposed to oxygen and water. Acid can form if iron sulfide minerals, pyrite, or fool's gold are abundant, and there is an insufficient amount of neutralizing material to counteract the acid formation. The acid will in turn leach or dissolve metals and other contaminants from mined materials and form a solution that is acidic, high in sulfate and metal rich, including elevated concentrations of cadmium, copper, lead, zinc, arsenic, etc. So leaching of toxic constituents such as arsenic, selenium, and metals can occur even if acidic conditions are not present. Elevated levels of cyanide and nitrogen components, ammonia, nitrate, nitrite can also be found in waters at mine sites from heap leaching and blasting. Therefore, acid mine drainage and contaminant leaching is the most important source of water quality impacts related to metallic ore mining. So, acid mine drainage is considered uh, one of the mining's most serious threats to water resources. A mine with acid mine drainage has the potential for long-term devastating impacts on rivers, streams, and aquatic life. You see in this figure, the water has become red in color, acidic water, which is very, very dangerous for the aquatic life and the human being. So how does it form? How the acid mine drainage take place? Acid mine drainage is a concern at many metal mines because metals such as gold, copper, silver, and molybdenum are often found in rock with sulfide minerals. When the sulfides in the rock are excavated and exposed to water and air during mining, they form sulfuric acid. This acidic water can contain metals in the surrounding rock. If uncontrolled, the acid mine drainage may run off into streams or rivers or leach into groundwater. Acid mine drainage may be released from any part of the mine where sulfides are exposed to air and water, including waste rock piles, tailings, open pits, underground tunnels, and leach pads. Harm to fish and other aquatic life take place because to fish, animals, and plants can be severe. Many streams impacted by acid mine drainage have a pH value of 4 or lower, similar to battery acid. Plants, animals, fish are unlikely to survive in streams such as this. So the toxic metals are also a great threat to the environment. Acid mine drainage also dissolves toxic metals such as copper, aluminum, cadmium, arsenic, lead, and mercury from the surrounding rock. These metals, particularly the iron, may coat the stream bottom with an orange-red colored slime called yellow boy. Even in very small amounts, metals can be toxic to humans and wildlife. Carried in water, the metals can travel for contaminating streams and groundwater for great distances. The impacts to aquatic life may range from immediate fish kills to sublethal impacts affecting growth, behavior, or the ability to reproduce. Metals are particularly problematic because they do not break down in the environment. The, they settle to the bottom and persist in the stream for long periods of time, providing a long-term source of contamination to the aquatic insects that live there and the fish that feed on them. So the acid mine drainage is a perpetual pollution uh, uh, which takes place in mining area. So acid mine drainage is particularly harmful because it can continue indefinitely, causing damage long after mining has ended. Due to the severity of water quality impacts from acid mine drainage, many hard rock mines across the West require water treatment in perpetuity. Even with existing technology, acid mine drainage is virtually impossible to stop once the reactions begin. To permit an acid generating mine means that future generations will take responsibility for a mine that must be managed for possibly hundreds of years. So in mining areas also erosion of soil take place and mine wastes also run to the surface water bodies. Erosion of soils and mine wastes run into the surface waters, particularly in waste dump area where the mining waste materials are dumped. So the leaching take place, erosion take place, and those waste materials, eroded rocks, they flow to the downstream rivers and ponds. So for most mining projects, the potential of soil and sediment eroding into and degrading surface water quality is a serious problem, according to a study commissioned by the European Union. Because of the large area of land disturbed uh, by mining operations and the large quantities of earthen materials exposed at sites, erosion can be a major concern at hard rock mining sites. Consequently, erosion control must be considered from the beginning of mining operations through completion of reclamation stage. Erosion may cause significant loading of the sediments and any entrant chemical pollutants to nearby water bodies, especially during severe storm events and high snow melt periods. Sediment-laden surface runoff typically originates as seed flow and collects in rills, natural channels, or gullies, or artificial conveyances. The ultimate deposition of the sediment may occur in surface waters, or it may be deposited within the fault plains of a stream valley. Historically, erosion and sedimentation processes have caused the buildup of thick layers of mineral fines and sediment within regional floodplains, and the alteration of aquatic habitat and the loss of storage capacity within surface waters. The main factors influencing erosion includes the volume and velocity of runoff from precipitation events, the rate of precipitation, infiltration downward through the soil, the amount of vegetative cover, the slope length, or the distance from the point of origin of overland flow to the point where deposition begins, and operational erosion control structures. Major sources of erosion, sediment loading at mining sites can include open pit areas, heap areas, dump areas, waste rock and overburden piles, tailings piles and dams, haul roads and access roads, areas, exploration areas, and reclamation areas. A further concern is that exposed materials from mining operations, mine workings, waste materials, contaminated soil may contribute to sediments with chemical pollutants, principally heavy metals. The variability in natural site conditions like vegetation, topography, climate, and proximity to and characteristics of surface waters combined with significant differences in the quantities and characteristics of exposed materials at mine sites preclude any generalization of the quantities and characteristics of sediment loading. The types of impacts associated with erosion and sedimentation are numerous, typically producing both short-term and long-term impacts. In surface waters, elevated concentrations of particulate matter in the water column can produce both chronic and acute toxic effects in fish. Sediments deposited in layers in floodplains or terrestrial ecosystems can produce many impacts associated with surface waters, groundwater, and terrestrial ecosystems. Minerals associated with deposited sediments may depress the pH of surface runoff, thereby mobilizing heavy metals that can infiltrate into the surrounding subsoil or can be carried away to nearby surface waters. The associated impacts could include substantial pH depression or metals loading to surface waters or persistent contamination of groundwater sources. The contaminated sediments may also lower the pH of soils to the extent that vegetation and suitable habitat are lost in the area. Beyond the potential for pollutant impacts on human and aquatic life, there are potential physical impacts associated with the increased runoff velocities and volumes from new land disturbance activities. Increased velocities and volumes can lead to downstream flooding, scoring of stream channels, and structural damage to bridge footings and culvert entries. In areas where air emissions have deposited acidic particles and the native vegetation has been destroyed, runoff has the potential to increase the rate of erosion and lead to removal of soil from the affected area. This is particularly true where the landscape is characterized by steep and rocky slopes. Once the soils have been removed, it is difficult for the environment. It is very difficult for environment uh, to difficult for the slope to be revegetated either naturally or with human assistance. So Environment Australia summarizes the problem as follows. Potentially adverse impacts of inadequate mine site water management and design include unacceptability, high levels of suspended solids, non-filterable uh, residue and dissolved solids, filterable residue in surface runoff, uh, bed, and bank erosion in waterways. It is self-evident that a sediment and erosion control plan is a fundamental component of a mine site water management plan. So acid mine drainage and water pollution is the main area where the mining people should give attention. Similarly, the impacts of tailing impoundments, waste rock, heap leach, uh, and dump leach facilities uh, are of great concern. The impacts of wet tailings impoundments, waste rock, heap leach, and dump leach facilities
Excuse me,
on
sir.
water quality. Yes, yes.
Sir, our other
So
class is
here, what I am telling is, and this document you should read. This document you should read once. What are the different phases of mining and how the environment is going to be affected? What are the things to be taken care of? So this is a reading material. Just you have to read and know what is a mining project. What are the things associated with it, how the environment is to be taken care of, what are the main concerns of your environmental dust pollution, noise, ground vibration, etc. There are so many environmental impacts associated with mining. So these things you should just read. Just this document I am giving you to read to know what are the things associated with it. So thank you for today's class. Thank you. Have a nice day. Tomorrow we'll meet at 8 o'clock. I'll tell you what are the type of questions going to be set in the examination. Thank you.
thank you, sir.
Thank you.
Thank you, sir.
Thank you.